With rates, we get into the meat of dimensional analysis, which at its core is about looking at the difference between different physical quantities in terms of their relationships to one another. And so with rates, we'll often have our units as fractions, and to do our conversions, we will handle the units of the numerator as one thing by putting the units we want to get rid of on the bottom and the ones we want to replace them with on top. And with the denominator, we will end up doing the opposite. We will take the units that we don't want and put them on top of our rates and replace them with the units we do want and put them on the bottom. A good example of this is blood sugar. In real life, blood sugar is commonly used to diagnose diseases such as diabetes. And we do that by looking at the amount of sugar, specifically glucose, in the blood, and we measure it in milligrams per deciliter or in millimoles per liter. And we can convert between one and the other because we know the molar mass of glucose, which is 180.156 grams per mole. And so we begin with a healthy adult's blood sugar being 108 milligrams per deciliter. And so to convert that, we want to get that into eventually millimoles per liter. At some point, we're going to have to convert our milligrams into moles. Well, before we can convert milligrams, we need that to be grams. Well, to convert that into grams, we know that 1,000 milligrams is the same thing as 1 gram. And then we can use this molar mass to convert to moles. 180.156 grams is equivalent to 1 mole of glucose. And then, to convert a millimole, if 1,000 milligrams is 1 gram, 1,000 millimeters is 1 meter, 1,000 milliliters is 1 liter, as you might guess, the nice thing about the metric system is that 1,000 millimoles is the same as 1 mole. Again, the units divide just like if they were variables, so the milligrams go away, the grams go away, and the moles go away. And so we're most of the way there. But we also need to take care of deciliters, because we're not looking at millimoles per deciliter, we're looking at millimoles per liter. If you look at your formula sheet, you'll see that 10 deciliters is 1 liter. Now, to get rid of deciliters, since they are already on the bottom, we need to put them on top. So I'm going to put 10 deciliters on top and replace that with 1 liter on the bottom. And now the deciliters divide out. And so as we go, we'll do the same thing. We divide by 1,000. We multiply by 1,000. In fact, a little bit of a shortcut here. You can actually just cross those out because if they're on the top and the bottom, they just divide, just like if you were multiplying fractions. And so all we actually have to do is divide by 180.156 and multiply by 10. And if I do that correctly, I will get about 5.9948 millimoles per liter. As with area and volume units, sometimes we have names for rates that you might not be familiar with that don't actually break down. For instance, oceanographers commonly measure flow of ocean currents in sverdrups, which is named after an oceanographer named Sverdrup. And we see that a sverdrup is equal to 1 million cubic meters per second. And it says here that the flow of fresh water from rivers into the ocean is about 1.2 sverdrups. And that's all of the fresh water going from rivers into the ocean every second. That's how many go in. And so we want to find this in cubic meters per day. So we begin with 1.2 sverdrup, and I'm going to multiply this, and to get rid of the sverdrups, I'm going to do something a little bit unusual. I am going to write 1 million cubic meters for every 1 second, but I'm also going to say that entire rate is 1 sverdrup. Now, we usually want to avoid a situation like this because it can turn out that with nested fractions, as you can see, they get pretty hard to work with. One thing we can do that is equivalent then to mitigate this is it actually turns out this is equivalent like that. And this is a lot easier to deal with. And now the sverdrups divide out. And so as you see here, 1.2 sverdrups is the same thing as 1.2 million cubic meters. And now we're going to take that 1.2 million cubic meters per second and use conversion rates to do 2 things. We want to convert meters into miles, and we want to also convert seconds into days. Well, it says here we're provided a rate, which is that 1 mile, is 1.60934 kilometers. But because we are taking this into the 3rd dimension, we will have to cube that. And before we can even use that, we also have to take 1,000 meters and convert that into 1 kilometer. And again, we do have to cube that. I will also take our kilometers and convert that into miles. And again, because we are dealing with cubic units, we will have to cube this as well. But if we do that correctly, again, the cubic meters will divide out, the cubic kilometers will divide out, and now we have cubic miles per second. And now, to make this a more manageable number, I want to convert that into days. This fortunately is not that difficult because we know that 60 seconds makes 1 minute, we know that 60 minutes makes 1 hour, and we know that 24 hours makes 1 day. Notice once again how I positioned these. Because I want to get rid of a unit in the denominator, I put it in the numerator over here. That will induce them to divide out. The minutes divide out, the hours divide out, and then when I divide by 1,000 cubed, which is going to be a very large number, it'll be a 1 with 9 zeros after it, we then divide by 1.60934 cubed, which is about 4.16815. When we finish with that, we multiply by 60, and multiply by 24. We see that this comes out to about 24.874 cubic miles a day. That is how much river water flows into our ocean every day, which, as we see, is quite a lot. Again, as you can see, all I am doing to convert units is to get rid of things on the top and on the bottom by positioning them opposite each other.